Take a close look at this massive, scale-covered formation resting in northeastern Thailand. Across algorithmic media feeds, you will hear a persistent, sensational narrative that claims this is a fossilized biological entity, perhaps a giant petrified snake or a cursed Naga spirit turned to stone. This animated diagram breaks down the actual science, showing the thermal strain equation acting on a cross-section of the rock. These formations are over 100,000 years old, and their geometry is driven entirely by a process called polygonal thermal weathering. The local Cretaceous sandstone in Bungkan possesses specific, measurable mechanical properties. It has a very low thermal conductivity, roughly 1.5 to 2.5 watts per meter Kelvin. It also has a moderate coefficient of linear thermal expansion, sitting at exactly 1.0 times 10 to the negative fifth inverse kelvins. The local climate subjects the sandstone to intense diurnal temperature fluctuations. The rock face absorbs intense solar radiation during the day, heating up rapidly, and then rapidly cools as temperatures drop at night. These extreme daily temperature differentials generate a cyclical thermal strain on the rock's surface. Expanding and contracting day after day for 100 millennia, the rock fractures into this highly regular, scale-like texture. Natural thermodynamic cycles operate on strict mathematical constants. These physical laws fully explain the geometries that populist media continually misinterprets as biology or magic. This misinterpretation carries a heavy cost. As the research notes verbatim, the physical modification of archaeological sites by alternative seekers looking for energy portals or hidden chambers often results in the permanent destruction of valuable stratified materials. When visitors take chisels and hammers to ancient rock faces to find hidden alien technology, they irrevocably destroy the actual archaeological record. To counter this, we will audit the raw thermal, acoustic, and chemical metrics that define anomalous historical sites, establishing the objective reality of ancient engineering. This forensic process often begins at the macro level, using geomorphic anomaly mapping to bridge the gap between quantitative topography and historical land use. This 3D topographical map demonstrates the GeoFusion 3D framework. By using UAV-mounted LiDAR, we can capture raw, uncompressed 3D point cloud data over massive areas without needing any historical baseline data. The system applies density-aware 3D clustering and principal component analysis, or PCA, to extract microscale geomorphic anomalies from the noise. The PCA-based residual depth metric mathematically isolates true terrain depletion patterns and highlights surface discontinuities. It removes regional slope-induced biases directly from the raw point cloud, completely bypassing the need for flattened, abstracted elevation models. By utilizing remote, zero-shot data processing frameworks, researchers can replace subjective historical guesswork with undeniable geospatial evidence. Shifting our forensic audit from lithic weathering to the physics of landscape acoustics, we look to the built environment of Chaco Canyon in New Mexico. This 3D digital elevation model displays the canyon's topography, loaded into a Python-based archaeoacoustics toolbox used to model sound propagation across complex landscapes. Sound propagation over this terrain is governed by a specific equation. The sound pressure level at any given distance equals the initial pressure level at 1 meter minus 20 times the base 10 logarithm of the distance minus two specific attenuation variables. The first variable, A sub atmosphere, accounts for the atmospheric attenuation coefficient, how much energy the sound wave loses to the air itself. The second variable, A sub barrier, accounts for the diffraction loss caused by intervening physical barriers, like vegetation or the canyon's topography. Within this acoustic landscape lies an anomaly the Navajo call Tse Binahot Sa Yalti. Here, ancestral Puebloanans deliberately removed approximately 360 cubic meters of solid bedrock from a canyon alcove. This massive excavation engineered a completely level, featureless amphitheater that projects a precise 340-meter diameter circle out onto the valley floor. The result of this geometry is the creation of a virtual sound image. At specific frequencies, standing waves form along the axis of the amphitheater, literally bathing the canyon floor in sustained sound. This high level of acoustic interaudibility was not a coincidental byproduct of the rocks. It was a highly engineered, decentralized civic ceremonial mechanism designed to control exactly who heard what and when. We can apply this exact same acoustic audit to the confined subterranean environments of the Cumberland Plateau. In his doctoral research, Jordan L. Schaefer mapped the archaeoacoustics of the 12th unnamed cave, a dark zone cave art site in Tennessee. When observing Paleolithic art like this, modern viewers treat it strictly as a visual medium, but mapping the cave's interior with 3D photogrammetry and localized acoustic measurements reveals a strict spatial correlation. The rock art panels were not placed randomly. There is a statistically significant link between the location of the art and exact points of high acoustic resonance within the cave. Furthermore, these specific locations generate a prominent, low-frequency ambient drone, heavily amplifying the sound of early hominid instruments or voices. The production of ancient rock art was intrinsically tied to a multisensory, performance-based understanding of structural acoustics. The physical science of sound directly governed the cosmology and rituals of these early societies. Moving from spatial acoustics to material transformations, we can audit engineered chemical states. Look at these early imperial Roman ruins at Monte Grotto Terme. The mortar holding these structures together requires microchemical phase analysis to decode. This data table and microscopic heat map visualize the results of quantitative phase analysis and SEM-EDS microchemical scanning applied to the mortar's volcanic aggregates. The data isolates an exact chemical anomaly. The Roman builders incorporated highly reactive angular trachytic to trachyandesitic volcanic breccias into the mix. The defining metric in these breccias is their massive amorphous fraction, which ranges strictly between 25.1 and 49.8% by weight. This substantial glassy matrix dictates the chemical reaction, controlling rapid and spatially variable crystallization kinetics when mixed with lime and water. The absence of specific high-temperature minerals like cristobalite and tridynamite in this matrix proves the material was not locally sourced, but transported directly from explosive diatremes in the Euganean Hills magmatic district. The phase analysis confirms that Roman builders commanded complex logistics networks and possessed an advanced understanding of how to engineer hydraulic pozzolanic reactions. We can scale this concept of material phase shifting up to entire defensive fortifications. In Northern Europe, pre-Viking vitrified hill forts, like the Broborg site in Sweden, showcase a deliberate manipulation of thermodynamics. The local gneissic granite boulders used to build the fort's ramparts possess an exceptionally high melting temperature, requiring over 1200 degrees Celsius to liquefy. To consolidate these massive stone walls, the ancient builders executed a deliberate thermodynamic fluxing strategy. They extracted a specific lower melting point rock called amphibolite, transported it to the site, and layered it within the timber-framed stone superstructure of the fort. When they set the wooden frame on fire, they created reducing conditions that drove the core temperatures up to 1200 degrees Celsius. The amphibolite melted first, creating a molten silicate liquid that coated and partially dissolved the surrounding granite. Upon cooling, this phase shift locked the boulders inside of deliberate, high-temperature thermodynamic engineering by indigenous populations. A severe modern paradox. Archaeometry offers unprecedented forensic fidelity, but the commercialized digital ecosystem aggressively marginalizes this data. Driven by nationalistic ideologies, populist distrust, and commercial exploitation, algorithmic bias inherently favors sensationalized pseudo-history over the peer-reviewed structural mechanics we've audited. This dynamic is not a benign internet curiosity. It poses a direct and physical threat to global cultural heritage conservation. Look at the precision of these massive, non-mortared lithic constructions in the Andes. Structures like these, along with Levantine basalt cooling joint monoliths, are prime targets for this algorithmic theft. The builders of these walls did not rely on lost super-civilizations. They relied on a highly sophisticated mastery of geotechnical stability, the strategic use of natural cooling joints, and the mechanical interlocking of multi-ton stones. Framing non-Western engineering achievements as the work of extraterrestrials or forgotten European empires is an active, systematic erasure of indigenous technological ingenuity. The true wonder of the ancient world lies strictly in its brutal, quantifiable physics, a reality we are rapidly losing to the algorithms of pseudo-history.